Thank you so much, ma'am, for the nice introduction and giving me the opportunity to take the this session related to blockchain technology. Thank you so much, ma'am. So, hello everyone, and I think I'm audible. So, we are going to do something that is related to smart contracts by using Solidity language and MetaMask. So, let me share my screen. Okay. So I think my screen is visible to all of you. And with this session, I'll be communicating with you and I'll be seeking some inputs from you all. So we'll be having an interactive session today. And meanwhile, I'll also ask you to do the same thing in your laptops or desktops wherever you are. And if you are in using mobile phones, so that is very unfortunate to like to deploy these smart contracts, but those people who are using their laptops, they can do with me. So the today's session, I'll commence it with the design of the smart contract. Later on, we will deploy that smart contract. So design and deployment of Solidity smart contracts. Why Solidity? Because Ethereum supports Solidity, and the EVM supports Solidity. So EVM is Ethereum virtual machine that supports Solidity as a language. So we'll gain the knowledge about programming elements of the Solidity language. Then we'll see there is a Remix IDE. So that is readily available. So you need not install any kind of compiler that is Solidity compiler. So Remix gives you an online Solidity compiler and an environment where you can, there is a small blockchain network where you can deploy your smart contract. You can interact with that smart contract by different users. Like there are 10 accounts earlier, and right now they are giving you 15 accounts. So using these 15 accounts, we can interact with the network by changing our role. Like I'm in the first account, second account, or third account. So I'll be in different accounts and I'll be, you know, communicating with that smart contract. Now, why we are creating the smart contract? So there should be a problem, like the problem whose solution we are going to design by using the smart contract. So we'll be having a scenario where there is a requirement of that smart contract, and we'll design as per the requirement. Okay. Now, for deployment of that for designing that contract, we need to identify the components, like what are the fundamental components that will be used in that contract to address that problem. So we will be recognizing those things, and we'll take in the map of Solidity in our mind to design the contract. And then we will be deploying. So Remix environment will give you both the environments, like designing the contract and deploying. So we'll keep on like trial and error method. Like we are going to write the code, then test the code, then whether the code is correct or not. So the compiler will, if it is not correct, the compiler will give you some kind of error, and it will suggest you that how you can do that. So using that environment, Remix environment, we can first compile the contract, and then if the contract is ready and each of the components are working properly, then we are going to deploy that contract. Okay. One more thing is there in today's session is MetaMask. So MetaMask is a D app. Basically, it is a wallet actually. So wallet we are having some ethers. So right now ether is very expensive to buy, but there are certain blockchain networks that are test networks though. So though they are test networks, but they will give you some ethers to for the testing purpose. So we cannot trade with that ether that we'll be having in our wallets, but we can use them for our small applications for testing purpose. So this is these are the things that we are going to cover in today's session. Next is what is Solidity actually? So Solidity is a programming language for writing the smart contracts. It's basic, like it is a very basic language that has the constructs which are very relative to the C and C++ languages or Java. If you have learned these kind of languages, Or if you are a naive person, like you are learning it for very first time, the coding sort of thing. So this solidity is not very much, it will be very easy for you to understand whatever is written in solidity language, because the names of the constructs or the components of solidity are very similar to the real life, like things. So you can easily understand, because they are in English language, so you can easily understand whatever it is used for. So first thing that comes to our mind when we are talking about solidity is it is contract oriented language. So it is not a that basic application programming language where you are developing an application like we are used to do in by using Java or C or C++. So we are going to create a contract by using the solidity language. So it means that we are going to create smart contracts using solidity language. Second thing is Solidity is designed to run on Ethereum virtual machine. So EVM is there. EVM is readily available with the Remix environment. So we need not install the EVM. Or when you're installing Solidity in your laptop, like separately, you're not using online version of Solidity, this Remix environment. So you can host your system to run EVM, and then inside EVM, Solidity will start working. So because it is a contract oriented language, we need a blockchain environment. So for that blockchain environment, EVM is there. So when you think about blockchain environment, think about Ethereum, like Ethereum virtual machine. And then if you want to code the contract, then you have to think about Solidity. So this is all about Solidity. Next is Remix IDE, that I've already told you that it is an IDE integrated development environment where you are having compiler, and then you can deploy that contract in a blockchain network that is given by this environment, this Remix IDE. So I'll tell you how you can open Remix IDE. So let us first see that how you can use Remix IDE, and then after that we'll see one scenario where we have to where there is a problem, and the solution is can be given using a contract. So we'll later on see this thing. So first thing is remix.ethereum.org. You can open this thing, this link. So Remix environment is there. So this is Remix. Okay. You can see this environment at your end, and I'll ask you to do this at your side also. So please open this Remix environment. I'm giving you this part of link in the chat, so you can copy this from the chat, and please let me know, because this is an interactive environment. I'm giving you hands on this development of smart contracts. So please please acknowledge me if I'm asking you something. So I think many of you have opened this in your laptop or desktop. So please let me know. So you can write Remix in the chat if you have opened this Remix ID at your end. Okay, good. So yeah, nice. Nice to see that many of you are doing with me. Yeah, that's great. So let's see what this environment shows you. So because I've already used this contract, this Remix ID for creating contracts. So I have some files that are over here. You may be having empty folder. Okay. So in the left pane, there is home button. So this is where we are right now. So by default, it is home. There is this link, File Explorer is there. So when you press on this thing, you'll get some folders that are default folders already prepared by the environment for you. One more thing is that since this Remix environment saves cookies, All right. Okay, so since this environment saves cookies at in your browser, so no need to log in for to fetch your file. So whenever you will uninstall your browser and then install it again, and then you will lose your files, like whatever Solidity files you have created earlier. So my suggestion is that whenever you will code a contract in Remix ID, you need to uh, do all the things, and then at the last you can save your file. Like if this is the file, then I have to right click on that, and then I have to download this file. So there are plenty options you can do that. So right now I'm asking you, what whenever you will write the contract, you can save it in your local machine. Second thing is that uh, here you can search for any of the, like if you are doing these creating these contracts for for a long time, so you can search for this. Third is this is the sign of Solidity compiler. So we are, what kind of files we are going to create right now is the Solidity files. So Solidity files have the extension of .sol. Okay, .sol. So sol is the extension for Solidity files. So whenever you are creating a contract, so you need, in Solidity, you need to have a file. Inside that, you are going to write the contract, and then the extension is sol. The last thing. So as I've shown you in this PPT, that first you are going to design the contract and you are going to deploy the contract. So for the deployment of that contract, there's one more option in this Remix ID, is this deploy and run transaction. So this is the Ethereum sign. You can see this, it is something like Ethereum. So Ethereum EVM will be given by this Solidity this Remix environment. So there is a compiler for Solidity, and then for deployment they will give you EVM. So how you have got the blockchain inside this environment. So you can, when you will press on this link, the deploy and this thing in the left pane, deploy and run transactions, you'll see that what environment you have been given by this Remix IDE. So when you'll click on that, you can see, yes, Remix VM Shanghai, Remix Virtual Machine Merge. So they have named them. Okay. So these are the remix. These are the remix. Sorry, these are the EVM virtual machine that are running. Certain forks are also available. So this is Ethereum mainnet. So Ethereum mainnet means where the actual Ethereum virtual machine is running, where the people are going to trade, like they are going to transact actually. So that is related to real money. So this is the main net for Ethereum. These are some of the networks that are for testing purpose. So Sepolia is there, Guerli is there, and there's one custom fork for if you are designing your own. Okay. There are certain providers like Hard Hat is there. So when you are deploying creating a small blockchain network at your end, local machine, so you can have Hard Hat for that. You can have Ganache. So the Ganache will be covered in tomorrow's session. So Mr. Sahu will be taking this, providing details about Ganache. So Ganache is also there, that can create for you a 10 account blockchain network where you can transact between these accounts, that will be totally in your local machine. Okay. And all that. So we have discussed it. So these are some of the environments that are already given for you. Then in each environment, suppose I'm taking this Shanghai. So there will be some accounts. So these are the nodes, actually, nodes, when you're talking about nodes in blockchain network. So these accounts are actually nodes, and for all these nodes, they are having 100 ethers in their wallet. So how many ethers are there? 100 ethers for each of these nodes. So how many nodes are there? There are 15 nodes. Okay. So this is the blockchain network that is named as Remix VM Shanghai, has 15 nodes Machine configuration for what? Shyam, Mr. Shyam, you are asking about what? Like machine configuration for what? I'm not getting. So please mention it in the chat while I'm explaining these things. So there are 15 accounts and each account is having 100 ethers. Okay. Okay. So for installation of, okay, Mr. Shyam, for installation of Ganache, you can have a minimum 4 GB RAM. So you can have a minimum 4 GB RAM, or you can have i3 or AMD processor for running this. This is a very small network that you can run very easily. There's no need to have a bigger RAM or something like that. Okay. Yeah. So there are 15 accounts, and each of these accounts are actually funded with 100 ethers, and you can transact with these ethers, but they are totally like they are not for real use. They are only for testing purpose. Now, when you are going to, like, if you are creating a contract that is payable, like not always every contract we use to transfer money. Like if the contract is supposed to only deploy for a certain, like for assets which are non-tangible, but they're not related to money. So and it is not always that contract is used to pay something, like to transfer the money. But yes, we need some money to make the transaction, like to deploy that contract. We need some money in our wallet, and to like to call a function from that contract, we need some money. So that is the ether, 100 ether that is given for you. So it takes very small amount of ether. So if you want to send some money, you have to directly send money to another wallet, then you can use this value option. Okay, we'll see that later on. And there is one thing, at address. So on what address you want to deploy the contract. So there is one thing, deployment of contract. So whomsoever his has the whole sole responsibility to have that contract. People also in other nodes also in that blockchain network, so they can communicate with you. So using these contract addresses, we can identify each other. So there are addresses also with these nodes. So each address is unique, and each address has some money. Okay, so by using at address copy paste, yeah, you can copy paste. Yeah, so I'm not right now deploying the contract, so I'm not copy and pasting that. I'm just giving you the overview of this remix ID. Okay, so this is what is a remix ID, and then we can use Solidity. Also, I'll ask you, since we are not having that much time to discuss all the components of Solidity, but you can go through this Solidity docs. So there are read docs for Solidity by Solidity. So from this, you can understand each and every component of Solidity, and you can design your own contract. And as per the requirement, you can use the components given in this documentation. So here you can have all these things. Okay. Now let's move to the presentation again, and then what we were discussing, we'll come back. So we have discussed Solidity, we have discussed Remix ID. Now imagine a scenario. So this is the season, as you can see that in India, there is a season of election, like campaigning, all that. Parties are there, national parties, local parties, they want to have a central government running by their party. So I've taken that scenario. So suppose there is a scenario where there is a national party that is a forum of leaders. So there is a forum of leaders of that party, or members of that party who are working for that party, and they want to have a new president. So they want to elect a new president for their party. So there is a requirement of election process. So a small election process in their party, like in any of the parties that are national parties in India, So you must have seen that there have been there is election process through which they elect their president. Okay. So for that election, the members of that party need that should be very transparent. Like nobody, there should not be any kind of discrepancy. Like there should not be any kind of misfavors. Like and there should not be any kind of you know like in while voting you are doing something that is wrong. So they need that the election of the president should be very transparent and secure, so that other parties should not also can have the influence on that thing also. So this is the environment that they need. So I think blockchain environment will be very suitable for this kind of problem, where you can have different nodes, like different people acting as a node inside that blockchain network, who are going to vote, for a particular person. And there will be a convener, or there will be a moderator who will run that thing, like who will organize the election, and the people who will be allowed to vote, they can vote. Okay, so there is the blockchain environment can very effectively handle this because of the distributed ledger technology. The system is very transparent, and because of crypto, this system is very secure. So both the things, like cryptography is involved and the transparency is involved. So this is very nice thing that we can have. So now, while designing this contract, we have to first identify that who will be the moderator, like who will organize this election process, and who will identify that the system is running very smoothly in a secured way and there is no discrepancy. So a moderator we will identify the moderator as a senior party member who will manage the in-house election process. Okay. In-house means because they have to elect their party president. So this is not that election that we are going to have like all over India. So that is not that. So in-house election process. Second thing is the candidates. Okay. So who is the candidate? Candidate is the person who wants to be the leader. Like I have the desire to become a president of that party, so I'll be the candidate. So moderator will identify the candidates. So I'll go to the moderator, that senior party member, whom I will express my desire to become president of that party. So I'll be for the election, I will be the candidate. Okay, and there will be voters. The people who can vote are the voters, and who are allowed to vote actually. So they are the voters of that party. So there are three stakeholders. Now the operations that we need in our contract to make a very small like contract, and the required like minimum number of required things that we need is, first thing is we have to identify the moderator. So when we are going to deploy the contract, we have to identify the moderator. Okay. Now that moderator has the responsibility to add the candidates to that contract. So suppose there are 3 candidates, A, B, and C. So they want to fight for that election. Like I want to be the president of that party. So moderator will add those candidates. There will be voter registration, like the persons who will be allowed to vote and who will not be allowed to vote, because everyone cannot be allowed to vote for that particular election process. Like from another party, people cannot vote. Okay. And a moderator has to set some policies, like if a person has already voted, he cannot vote again. And if he has voted, so whom he has voted to, so if there is some, if somebody asks that no, I voted to A, but B has won, how? If there is something, so this blockchain can store that information also, that whom you have voted. And since blockchain has the capability that you cannot mutate, like you cannot change the ledger. So if once it has been recorded that whom you have voted, then it is recorded. You cannot change it. Okay. So there is, transparency. And finally, if the election is over, the moderator identifies the winner, who will be the president of that party. So these are some of the small operations, some very basic operations that we require. Okay. So now we have, because we have, this is the design, like this is a sort of thing that is a non-technical kind of thing. So we have designed. Now we are going into the technicality, how we can deploy these operations. So first thing is that we need to identify a moderator. So we can do this by the person who will be deploying the contract will be the moderator. Okay, so the constructor we will use for that. So deployment of contract, constructor is called actually. So because it is contract oriented language, so contract oriented language is very similar to object oriented language. Okay, so in this contract oriented language, we are having also having here also we are having constructors. Okay, then there will be a function. So there will be function that we will design where only moderator can call that function, and then moderator can add the candidates. Okay, so using that function we can add the candidates. Second is we can register, we can do voter registration. So first is adding the candidates. Moderator can add the candidates through a function, a specific function. There will be another function where we can do the voter registration. Okay. Third will be the function that will third will be the thing that that function should have certain conditions. Like if that function is being called, a certain condition should be checked before. Like there should be a pre-check for those conditions. So we will add modifiers. I'll tell you what is modifier. So modifier is what something that checks whether that particular thing that function can be called or not. Okay. So we will set the modifier in case of rights to have vote, and in case of when if she or he has voted, then he or she cannot vote again. So in both the cases. And finally, we'll call a function that will that moderator will call for identification of that winner. Okay, so let's start the coding of this contract. So again, I'll ask everyone to come back to the remix ID. So this is yeah, this is my remix ID. So I'll ask everyone to create a file. So when you are at the remix ID, at the left pane there is a file explorer. So when you click on that, this file explorer, there's one option for creation of new file. So I'll click on that. You can see at the last there is a blank text box coming. In that text box I can write. So this is Asia Connect, Asia Con, and then I'm writing solidity, and then voting or election. So election and dot sol. So I think this you have to do, and please let me know in the chat if you have created the file. So you can write in the chat. Oh, screen is not visible. Oh, let me share once again. Oh, I'm very sorry. Right now, is it visible? Okay. So this is where you can create. Okay, I'll repeat. This is the dot. This is the address So you will open this remix.org. You will be in the home screen. This is the home screen. So you need to create a blank solidity file where you are going to write the code. Okay. So the blank solidity file, how you can create that? You have to just go to this icon that is for home, this remix ID icon. You can see that there is a file explorer button. So I'll click on that. So you'll see the file explorer. So you can do one thing. Beside this drop down, this is a drop down. Okay. Beside this, there is a create new file option. So I'll click on that. This I'll write Asia Connect, or so I'll write election AsiaCon .sol, and this is the after I have pressed the enter button, there's a new file. This is the file, that is, you can see the name of this file. So it will give you some kind of tabs, like in like we used to have in the browsers, so something like that. So in a tab there will be a blank file. So this is sol. So please let me know if you have created this solidity file. So you can write created in the chat. Okay. Okay, good. So many of you have created, and still you will be creating. So first thing, okay, so we will be giving you, no, Sanskriti, we will be giving you the recordings for this. So because we are running short of time, so we are not, we will not be repeating right now. You will be given this recording for this session, and then you can do that. Yeah. Thanks everyone for acknowledging me. Yeah. Okay. 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 Thanks, Sanskriti. So first thing is that we have to write pragma solidity. Just write this, I'll tell you. Greater than equal to, and whatever version, 0.8.0, or I'm writing 0.5.0, and then semicolon. Just write this thing. So pragma directive, just like hash in when we used to do coding in C and C++. So we were writing earlier like hash include this. So in this case, we are specifying using pragma directive that yes, whatever solidity version we are using right now. So there are many solidity versions that are available here. When you will click on this solidity icon, you'll see that when you will explore this drop down, you can see that there are a number of solidity versions that are given to you, like starting from 0.1.1 and the latest being 0.8.20, that is the stable. So stable version. So we are using right now 0.5.0. Okay, 0.5.0. We can use that. No, so there is no login. Yeah. Narayan Bhushan, Mr. Narayan Bhushan, there is no login required. Okay, so we'll be using Solidity version 0.5. So I'll use that 0.5.0 comment. I'll select that right now. So I've selected. Now we'll start the coding. Since Solidity is can use any version, Neetu Sharma. Yes, you can use any version, but according to that version, you have to change the code in case there you will find an error. Or if there is no error, there is no problem. So because it is ever changing, like it keeps on changing, the languages are kept changing, so they are given with the version. So suppose I'm giving a solution to a particular company, so I'll specify the version, in which version we need the compiler to be installed in a local machine. So this is what, because okay, so how to select is you have to go to this Solidity icon, then you can scroll it down to 0.5.0, then you can select it, and then that's all. Okay. Now we are going in the phase of writing the contract. So since the Solidity is contract oriented language, just like object oriented programming languages where we used to write the class, here you have to write the name contract. Okay, so contract election. I'm writing contract election, and then you have to open the brace and close the brace. So it will give you this thing. Okay, so contract election, we are now going to create a contract for election. So contract election. Now, first thing is that comes to our mind when we look upon that slide that I've already shared with you earlier. So in that PPT, we were first identifying the moderator. So we have to, because this is a contract, we are running this contract in a blockchain environment. So can anyone tell me how the people in blockchain network can be identified when we are using EVM or remix environment? How we can identify them? I've already told you earlier. How we can identify each node in a blockchain network? Any answer? Using addresses. Very nice. Very nice. So unique ID will be no. Accounts. Yes. Accounts is good, right answer, and addresses. Actually, yeah. Nice. So we will use. We will write the name. We will use a variable to store the address of the moderator. Yes. So first we will declare the moderator. So moderator will be declared with the address. So address public moderator. So here, yeah, we can say that, Shyamji, we can say that these are wallet accounts. Yeah. So all these are wallet accounts, and these are having 100 ethers. Okay. So address public moderator. Now, each candidate will have, so suppose suppose make yourself as a candidate. If you are going to become the president of that party, you have the desire to become that. So you are having what? You should have some name. And second thing is what? You should have some vote count, like how many votes you have got. From that only, like in India, when you are going to elect somebody, so there is vote count, and there you'll find that from how many votes he have won or she have won. So we need to specify a candidate, since there are two things that are required. First is name, and second is vote count. So we need to put them in a single data structure, that is a structure. Okay. So struct candidate, and inside this structure, there'll be two things. First will be the name of that candidate. So the data type for that candidate will be string. So string name. So this is the name for that candidate that will be stored. And second thing is vote count. How much votes he or she have got. These are the two things. Okay. So this is a single candidate will have two things, name and vote count. Okay. So this is very similar to C language or C++, where you are going to create the structures. Okay. And basically C++, like more closer to C++, where you are going to use a class, but in this case, you are going to create a contract. And inside that class, we are going to use the structures. So that is what we are using right now. Now, same is for voter. So struct voter. Okay. So what the voter, what the things a voter should have? What are the things? Like for this thing, think from the view of moderator. So first thing is that we are giving permission to vote. First thing is that we are giving permission to vote, and then we are identifying if he has been granted the permission to vote, he can vote. first thing. And if he has voted, he cannot vote again. So these two things will take into account. Okay. So let's see if she has voted. So Boolean variable will take. So bool if voter means she has been given the right to vote. And bool if voted, it means that no Anilji. Everything will be inside this contract file. Yeah. So if she has voted, she cannot vote again. Okay. So we have to initialize these two variables for that voter by becoming a moderator. So when we will be moderator, we will be setting these two Boolean variables. So Boolean is what? Can anybody tell me what is Boolean? Boolean values? Exactly. True or false, 0 or 1. Yeah. Yeah. Thanks. So just want to check if you are very comfortable with the programming languages. Okay. So this is only for yes or no, true or false, 0 or 1. Okay. Now, first we have to create the constructor. Okay. So we will create or some one more thing. We are going to create the array for these people, for candidates. So we are going to create an array for candidates. So we'll try to create an array. So that array will have those candidates. Okay. So candidate. So this is the structure. Okay. So uh, candidate, public, and then name of the structure, like what is the data type. So it will be like, what is the name of array? So it is like name of array. Then we have put this thing for showing that we are going to create array. Then what is the modifier? Access modifier. So public is the access modifier because we are going to use this array outside this contract. So this public, and then the name, that like data type. So data type is candidate. Okay. Oh, should write like this. So we'll write like this. Candidate is the name of data type. So we should it is in opposite, like, okay. So first is data type, and then it is the name. Okay. So this is you have to change it because in C we are going to name it first, but here we are going to decide what is the data type, then what is the type, like what we are going to create, the access, and then the name of that data type. So I'm going to use candidate as this capital C, or candidates. Okay. So like this. So please keep on writing with me. Now, second thing is voters will be identified with the help of, with the help of their addresses. Okay. So we are not going to write anything for the voter. Okay. So for any array sort of thing for voter. Okay. Second thing is that there is a mapping, address mapping also. So if time permits me, then I'll tell you what is address mapping. Okay. Right now we are going to use array. Now, one more thing is modifiers. Modifiers are actually something that we are going to use for like checking the conditions in that function. Like when that function is called, you have certain condition that should be checked first, and then we can call that function if those conditions are met, like they are true. So yes. So let's do that. So we are going to create the modifiers. Okay. So we are going to first add one modifier. So modifier, you have to write modifier. So this is for checking the condition. So modifier, what is open? Yeah. Modifier only voter. So this only voter modifier will check that only voters can vote for this thing. Okay. Only voters can vote. So there is some requirement. So require, you have to write require. So there's a condition inside require. Okay. So what is the condition? We have to write inside the requires that voter. Okay, we have to create. I think now there is requirement of. I'll tell you. So first thing is we are going to use address mapping. So I'll tell you what is mapping. Okay, so right, just like in this way, and I'm going to tell you. So mapping from what address to voter. So address to, and then we are going to use this voter. So voter, and then we'll name this as public voters, and we'll use the same, like capital C is there for candidates, so we'll use capital V so that we are going to easily identify that for what it is used. So what is this mapping? Mapping is that using some address, we are identifying the voter. So voter has some address. So from that address, we are identifying the voter. So every address who is voter will have two things. If two Boolean variables, if that person has been given right to vote, so if that is voter, or if he is voter or she is voter, she has voted or not. So these two things we can have for a particular address if that address is identified as voter. So we are going to make this modifier again. Okay. So modifier only voter, require that it is required that this voters, it has some address. So from this address, we are identifying this voter. It has two variables. So if voter value, this Boolean variable is actually false. Okay. Okay, if it is false, then he or she cannot vote. So it must be true because it is requirement. The requirement is what? It must be true. So double equals to true. It must be true. So if it is true, then only we will allow that person to give vote. Okay. Otherwise, we'll write the thing like you, otherwise, this is for otherwise, like if it is not true, you are not allowed to vote because you have this condition as false. So this is false part and this is the condition. If the condition becomes true, we will not go to this false part. Okay. And if this condition is false, then we will go to the false part and then we will tell that what is the problem? Why this function has not been called? Because you are not allowed to vote. Okay. Same way, we will again design another modifier that if you have voted, like we have to give right to vote. Okay. So if if voted, first thing is that if voted. Okay. Second thing is that modifier if voted. If voted. So if voter and if voted. So voter's address if voted is true. So you have already voted. So you have already voted, not given the second chance. I'll tell you, not given the second chance. This is what we can have, two modifiers. Okay. So only voter and if voted. Now we are going to use these modifiers in a function. So now we are going to create the functions, but very first thing, that is something like a like to function, is the constructor. So we are going to create a constructor. So you'll write constructor. So you'll write how many candidates we want to add. Okay. So, or we'll not give this thing. We will add these candidates. Okay. So this constructor should be public, and then what we can do is we have to identify the moderator. Okay. So we have some moderator we have defined. No. So we have to define a moderator. I'll define it first, and then I'll use that in constructor. So we'll define a moderator. Moderator is something that who has some address. Okay. So address public moderator. So, and moderator, this moderator equals to message dot sender. Okay. So what is this? Okay. So this is moderator's address. And that is uninitialized. This is not initialized. But when the contract will be deployed, this will get initialized. So this message dot sender will be the account. So message dot sender is the account on which the contract is deployed. The contract is deployed. Okay. So message dot sender is the account on which contract is deployed. So moderator will be the person who will deploy the contract. Okay. Oh, yeah. So Mr. Prasad, this is what, like, we can use a double slash to write the comments. Yeah. So I'm writing the comments with each code. Okay. Now, let us check. Yes, in require, whatever we will write, yeah, we have to terminate it. One more thing is that whenever we are going to write the modifiers, we have to add an underscore with semicolon at the last line. This is why, because this is the pre-check, pre-condition. So whenever this is added, the Solidity compilers takes it like first that you have to check. So in both the modifiers, you have to add underscore and semicolon. Underscore and semicolon in both the modifiers. Okay. This. Now we have a constructor. So what we have done till now, we have created two. Okay, we have already expressed this, specified this moderator. Okay, so I'll use that one, the earlier one. Okay, I thought I have not written it, and then I'll delete this thing. Yeah. Okay. So we have specified the one address that will be of moderator. We have specified two structures. One is for candidate, one is for voter. Then for candidates, we have created one array. For voters, we have created a mapping. Okay, so there are two things. This is what is actually array. So this is array. And this is actually mapping. So this is mapping. So we'll call it as mapping. And this will be array. So mapping is always by using one thing, just like associative memories if you are from a computer science background, or just like hash key. So you are using from that key, you are going to some value. So here from this key, that is address, we are going to voter. Okay, one and the same thing. Now we have specified two modifiers, only voter and if voted. Both of them use require this condition, and the condition is specified over here. This should be very true. If it is not true, then the false part is this, and that will be printed. Okay. And then we are having constructor. Constructor is what it is doing. It is initializing this moderator that we have already declared earlier in this contract. Now there comes the question about the functions. We need to have some functions. So the first function that comes to our mind is we have to give right to vote to certain people. So function give right to vote. We are giving, we are writing a function. That function should, like using that function, the moderator will give right to vote to a specific person, like a specific candidate. Okay. So what we will do, we will, because voters are identified through addresses. So we need to give one address to this. So address, and this is voter. Okay. I'm specifying this underscore so that we will always see that this is actually a local variable to this function. So address voter and public and this function. Okay. Yeah. So one more thing comes to my mind, that can anybody give right to vote to any person? Is it allowed to any person during the election process that he or she can give vote? Or who is the person you will identify that he has the responsibility to give the rights? Anybody? You can give me in the chat the answer for this. Yes, of course. That will be moderator. So moderator will be allowed, only moderator can do this thing. So we'll again specify one more modifier, that is only moderator can do certain kind of things. So only moderator. Only moderator. Okay. What is the requirement? What is the requirement? That whomsoever is calling that function, that will be message.sender. Whomsoever will be calling this function. Whomsoever will be calling this function will be message.sender. That should be the moderator. That should be moderator. Or we can specify you are not authorized. You are not authorized. So only moderator can do this thing. So public, and we can specify moderator can do this thing. Okay, so only moderator is the requirement. Now, give right to vote. To whom? This voter. Okay, and this voter, there is some address. So through this address, we will identify the voter. So this address is this address. Through this address, we will identify the voter. Okay, and the voter has what? If voter and if voted. So give right to vote. Now I'm giving right to vote. How we can do that is first thing is that because we are not using array. So yes, voter, we will take the mapping. So what is the name of that mapping? Voters. Yeah, voters. Voters. Then voter. This voter. This is the local variable that is bringing the address to this place. So voters, this address dot if voter please excuse me for important one. Yeah. Okay. So voter, and then if this Boolean variable has to be set. So if voter, it should be set to what? If I'm giving right to vote to somebody, what should I set to this Boolean variable? True or false? What should I set? If I'm giving right. Yeah, Kuldeep, yes. What about others? Should I give, if I'm allowing somebody to, I'm allowing somebody to vote. So it should be set to yes. Yeah. So true. Okay. So you can write true. Give right to vote. And then when you will check the condition, if he or she has voted, when you are that function is giving vote, and then again you are setting that flag that if somebody has voted, then please make it true. Then we can check the condition. I'll tell you later. Okay. So function give right to vote is this thing. Now give right to vote we have given. Then we have to design a function for voting. Okay. One function we forgot, like function add candidate. We have not added the candidate yet. Add candidate. Okay. So function add candidate. So here we have to add the candidate by his or her name, because there are two things, names and vote count. So a string name underscore name. Okay. And initially the vote count will be 0. So no need to take that thing. Okay. So public, and the person who can only call this function is the moderator. So we will add this requirement, public only moderator. Okay. And then what we are going to do is we are adding that thing. So to add something in an array, we use push function, this push. Okay. So we are going to push on which array? So it is, or what we have specified is candidates array. So inside this candidates array, we are going to push. Now what we are going to push is the name. Okay. So we have to specify a candidate. Okay. So a candidate. So candidate, a structure, because it is a structure. So structure is going to get pushed. So this is a structure. Okay. It is going to get pushed. And we have to give the names of those variables. So first is name and second one is vote count. So I'll write name. So name is what? Name. This. Second thing is what? Vote count. So vote count. and vote count is actually 0 right now. Okay, so this is what we need. Then we have to close this thing. We have closed this thing, yeah. Yeah, one more thing. We need this candidate. Yeah, because I remember that there is some parenthesis. Yeah. So what you are doing in this function? If you are calling this function add candidate, so who will call this function? Moderator will call this function. So moderator will add the candidate to this array. Okay, this array. The name of this array is candidates. So what has to be inserted is the structure. And what structure has two things, name and vote count. So in the candidates array, we are pushing a candidate that has some name and initial vote count as 0. Okay, so by default, initially, all the candidates will have vote count as 0. Okay, this is what we have done. Now, so you can see over here that we have created a function. Okay, so now we have to create a function to what? Vote. So function vote. Okay, so function vote. Now, we'll have one thing. We'll use the index value. Okay, so since in the election process we only have like symbols and all that, so we will like numbers is there. So there will be 3 candidates. So we will use index number of candidate to whom we will or we are going to vote. Okay, so function vote, and then we will write uint because the array indexes are always uint. Okay, that are not signed, like they cannot be negative. So we'll take it like because it is voter. So uint candidate. Okay, so cand index. Okay, so that will be far more better for you to understand. Now there are 2 conditions, like who can vote. So this function first will identify everybody can call this function. Yes, everybody can call this function because they are voting. But who can vote? So only if he is voter, and if he has voted, so it should not be there. Like this is a condition that should not meet. So we will make it a complement of this condition. If not voted, must be false. Yeah, must be false. So if only voter and if not voted, so we'll write only voter and if not voted. Not voted. These 2 things. So if he or she is voter and if not voted, then only we can, like he or she can call this function. Now both the conditions are met. Like he is voter, he has been allowed to vote, and he has not voted yet. So what we will do is we will update, like we will change the values for that voter. Like if he has voted, so if voted should be like true, and then whom he has voted, so for that candidate we have to add something, like so for that candidate the value should change, the vote count should be incremented. Okay, so let's do that. So
we'll use mapping. Yeah, so message dot sender will be the one who is right now voting. So this is the address. Now voter. Okay, voter is actually voters. Yeah. So this we will use. So voters message dot sender, and then it's dot if voted should be made as equals to true, because he has now voted. And whom he has voted, so what we will do, candidates array we will use. So candidates array, just like this, candidates, and then we will use this thing like inside candidates, we'll use candidate index. So index, candidate index, and dot vote count. So we have to increment that vote count. So plus equals to 1. So this person who is the voter, and if she has not voted, so she is going to vote this candidate. So that candidate will have vote count equal to 1. And that voter, because that voter has voted, then if voted should be made true. So two things we have done in the single function. So two changes. Okay. So the vote count of that particular candidate is now changed. Okay. Now, third thing is that now voting is done. Now the major part is what we have to compute, that we have to identify the the person with highest votes. Okay. So we will create a function that will identify the winner. Okay. So function find winner, find president or winner. Okay. So find winner is the function that can only be called with the help of moderator. Okay. So only moderator can do that. Now, we forgot to write public. Yeah, Mansi. I'm very much, yes, it is correct, but not so difficult. Like if you try, then you will be able to do that thing, because if we are not giving you hands-on for this thing, you'll not be able to connect with the real things, like how this is going to happen, how we write the contracts, how you are going to do that. So for a non-IT candidate, it is not that much difficult if you will try to do this. Like at your home, you can watch this video and then you can do that. It is very easy after that. So when you will try, then you will be able to do that. Now, this is only moderator can do this thing. So now I'm going to write this function. So first thing is that we have to count. We have to count that how many votes each and every candidate has got. Okay. So for that, we have to run a loop. Okay. So let's create a variable winner vote count. So winner, okay, vote count. Initially, winner vote count is 0. And second thing is, we will identify the winner. So how we will identify the winner? Because winner will be a candidate. So there is a an array. So we will identify the winner as the index value by using the index value. So winner index, we'll write winner index, uint winner index. So index is initially, we will by default, we'll take it as 0. Like first person is the winner right now. Let's take it, and then we will identify. So while starting, we will default, by default, it is the first person. Now, so we'll write for loop. So for uint I equals to 0, I is less than. Now we have to, like, for every candidate, we have to check that what is the vote count. So the length of the array is, how we can identify is the name of that array. So the name is candidates dot length. Okay, just like in Java. So candidates dot length and then I plus plus. This is what is the for loop, and then we'll identify. Okay, if the current person, so because first we have already taken default, so we'll try it with 1. Okay, so if the current candidate, so candidates I, so the current candidates. So if the current candidate, because we have started it with 0, like initially the candidate winner is 0. Now we are checking it with 1. So 0 is compared with 1. If 1 is having higher votes than the winner index. So candidates so if this new candidate has higher votes than this winner candidate, the new will be winner. So how we will do that is winner index will be updated with new, because new, this I is having greater value. So candidates I is the vote count. Suppose like can 0 is having 10 votes, can 1 is having 20 votes, and can 3 is having 3 votes only. Okay, so default is 0. So winner index is 0. Initially we are over here. Now we are comparing with it with 20. So 10 is greater than, sorry, 20 is greater than 10, because I is at this person. So 20 is greater than 10, condition is true. It is saying that winner index will be I. So winner index will be this, with this. Now when again loop starts, it will check 3 and 20. So if 3 is greater than 20, no, 3 is not greater than 20. So this will remain as winner. So here we have got the winner. After this for loop, we have got the winner. Now we will return something. Okay. So public only moderator returns. Or we will not make a returning function. We will make one variable uint winner index. Okay. So after this loop, this winner index, that is a global variable for this whole contract, will have okay, so winner index, final winner index. So final winner index will have this winner index, this thing. Okay, so we have identified the winner, and then we have to declare the winner. So to declare the winner, we'll find with this thing. Okay. Okay. So yeah, using winner index, we'll find the winner. Okay. Because or we will use returns, but okay, let it be. So we'll do that, and then we'll identify the winner. So first of all, we'll see. No, Dr. Kunj Bihari ji, we cannot import any inbuilt function of other programming language. Okay, in this Solidity, we cannot do that because these are two different platforms. So they Solidity compiler will not be able to understand Python or MATLAB. So you have to design it in the Solidity language only. So let us see that we have written it correctly, and we have done all these things. Like first is we have taken a moderator, candidate, voter. The functions like give right to vote. Yes, this function can only be called with moderator. Yes. Add candidate. Yes. Then vote. And if voting completes, then we will find the winner. Okay. Okay. That seems to be complete. Okay. So let's do this thing. If you have written this thing, please let me know. Yeah. Yeah, it's very long program, but it makes some sense actually. So while writing a chunks of codes in Solidity, will not be able to understand why we are writing the contract. So our motive or our idea was to give you an insight about that how you can have a complete application of a contract. Yeah. So yes, thanks, Mansi ji. Let me compile this and then I'll share it with you, like this Solidity program. Okay. So let's compile and fingers crossed. Oh, so there was some problem with constructor. So let's go there. So it happens that sometimes like although we have written it very carefully, but there are certain things that we are not able to write it correctly, and there are some errors. So constructor public. Oh, I see. Yeah. So expected colon, but we have used equal to. Yes, for vote count, that should be not be equal to, so it should be vote count colon. Yes. And then yeah. So yeah, this is very modifier body does not contain. Yes. So in this modifier, yeah, only moderator, we have not added underscore and this. One very important thing is when we are going to use strings. So let me again compile this and I'll tell you this about this error. So when we are going to use strings, we have to specify a memory keyword. Okay. So there is a keyword that is memory, and that keyword has to be specified before after declaring the data type and before the name of that variable. So string memory name. Okay. So okay. Yes. So that is message dot sender. That will be always message dot sender. and it is saying that compatible, not compatible with types of candidate storage reference. Okay, so this is yeah, what it is saying
Samir, can we
is,
have a small break?
yeah,
Some
ma'am. Yeah.
questions. It seems that people are there from other disciplines as well,
Yes,
and
ma'am. Yes,
for them it's becoming a little too complicated, perhaps.
yes,
So while you are doing it, I would like to address, while you are searching for, those things, what I can do is that I can answer some of the questions, if you don't mind.
yes, ma'am. Yes, ma'am. Yes, ma'am. Sure, sure.
Okay. So, well, it seems that we have people in this group with diverse background, and I'm happy that some of you are asking for things. It's a very long program. Well, generally, smart contracts are to be written in a very simple. They have to be very simple, so that understanding their logic and verifying if the smart contracts are correct or not becomes easy, right? Of course, for CS people, these programs appear to be small. For people from other disciplines, it may appear to be difficult. Now, what I wanted to tell is that even if you are not from the CS or computer science or IT background, you can play a very important role in the blockchain technology. The reason is that blockchain technology is not only coding or computer science, but it is a technology that involves people from all background. It's a multidisciplinary kind of technology. And in years to come, people who have worked on blockchain, who have conceived the idea of the blockchain, say that it is something like electricity. The people who invented how a bulb, like how electricity, like how to light a bulb, never knew that electricity will become an essential commodity. Or people who first developed the idea of internet never knew that internet will be used in such a way that it will become an integral part of our lives. So same way, blockchain technology is going to be embedded in our system, in our lives, and this. So starting from the network creation, we don't need for network creation any smart contracts, right? You can create a network with a very simple, any difficult smart contract with very simple rules, which can be put in a smart contract. You can create a network of your own. For applications, because it is a peer-to-peer network, every single thing has to be well recorded for transactions, all kind of transactions, communications, queries, updates on any state of any network. We need to have every single thing that is to be recorded. So if you are not from CS background, what you can do is that you can write your specification of your requirement for which business you wish to adopt the blockchain technology. So for example, for MES services here in our institute, if I wish to introduce this idea that any student can punch his card and get the services, accordingly, the amount will be deducted. If he does not turn up, then the amount will not be deducted. And based on a minimum number of meals that he takes, he becomes a member of this MES services. And if the MES wala is not able to provide services, how the penalties can be imposed and what will be the consensus mechanism for the penalty. All these rules we can define, and then we can hire a person who can code it for our purpose. So not everybody, you can still create a blockchain network and write small piece of codes to run the network. So, for example, if it is a voting proposal, I want to create a voting system which is completely transparent, secure, and also immutable. How do I do that? Perhaps for that, Samir is telling you that it is a voting. Basically, the idea is to create a voting system which is transparent, immutable, and secure as well. So, and it also preserves your confidentiality, right? So there are many applications where we can have contribution of all people from all disciplines. Some people have written that you are going very fast, Samir. So we are sorry. I think you can redo. You can just go through the this lecture again, and you can take a glimpse. You can perhaps start learning in a later period. Over to you, Samir. I think I've answered some questions which were arising.
Yeah, ma'am. Yeah, ma'am. So, yeah, I'm very sorry that I was very fast, but because some of you are.
You were perhaps going with pace, but the only thing is that for some people, it's a diverse, it's a heterogeneous group.
Yes, ma'am.
And
Yes,
so
ma'am.
not to worry, if you are not able to understand now, just review the video, and we will be helping you in best possible way in future as well. Don't worry about it. That's what I wanted
Yeah,
to
ma'am.
convey.
Yeah.
Thank you.
Yeah. Even when, yes, ma'am. Thank you so much, ma'am. So even when you will read this contract for 2 or 3 times, so you'll be able to understand, you will be able to connect everything, that why it has been taken and why this array has been taken, where we have to take this memory. And even because we have given you a certain functionality in this contract, so when you will be designing your own contract somewhere, this will be very helpful to you. So there are 2 motives. Like, first is to provide the glimpse. Second is to provide something that you will be able to apply in the future also, like do something. Yeah. So definitely we will give you the video, and you will be able to do that. Okay. So we were here, there was an error coming. So don't worry about errors. These errors are very simple if you know the programming. So first thing is that candidates, okay, it is giving you candidates error. So actually what is the error is, actually we have to compare the vote count. So each candidate's vote count. So we have not given, because we are comparing here with addresses. Addresses are not comparable, but the vote count. So we have to add vote count. So dot vote count. Yeah. So this has to be there. And again, yeah. Now this is compiled. Our code is compiled. You can see over here. So this unused local variable. Okay. So it is giving us, we are not using. So this local variable. Okay. Then, yeah. So winner vote count, we will use this. So winner vote count. So will you make one more variable? Final winner vote count. So we'll write it over here. Final winner vote count is actually winner vote count. That after this loop we have taken out. So again we will compile. So whatever changes you will make, you have to compile it again. Okay. So if you're not compiling it again, then you will receive some, errors and something that you will not be able to find it out, crack that what is the actually why this error is coming. And Sir, what are the basic tools needed to work with blockchain? Okay, so basic tools that we need in case of programming, or in what context you are asking me? Mekla Sharma. So please specify that on what context you are asking. Okay, so since we have compiled, some people have written that they have got. Let me first go to this file. So this is Election Asia Con. Okay, this file. So first let me download this file and give it to you all. So desktop, yeah, and then okay, from Google Drive I have to. Yeah. Let me check if I can give you this file. So okay, I'll give you the link. Okay. Yeah, thank you. So I'm creating a new folder here. I'm not okay. So when I'll be getting the permission to add something to this drive, I'll give you the file. Meanwhile, I can copy this code. Yeah, I can do that. So this code, yeah, this one in the remix ID. I'll copy this. I'll give it to you in the chat, so you can directly copy it and then run it. Okay, so let me.
We will also provide you the material. Don't worry about it.
Okay.
So
Yeah.
we will provide
Okay,
you the
I'll give
complete
them
material.
yeah. Yeah.
And the instructions to run the code, if you can do that, Samir. We will do that. Thank you.
Yes, ma'am. Yes, ma'am. Sure. Sure. So right now I'm not able to copy and paste this code because the length is too more like too big. So
that's what I was saying. That is why I told
yes,
that we will give this material. Don't worry about it.
Yes, ma'am. Yes, ma'am. So this is what we have done right now. We have compiled the contract. So first thing that we have designed the contract. So as per these slides, what we have done, we have designed the contract, and then we are going to deploy this contract, deploy the contract in Remix environment. So first thing is that let's do that. So for deployment of this contract, please go to this link, like this icon for deployment at the left side in the left pane. So you click on that. I'm here. Now you have to take one of the VMs given by Remix right now. So I'm taking any of the VMs like London, Berlin. So this is London I've taken. So there are 15 addresses that we have got in this environment. So now I've selected the first account. So this first account, because I'm deploying this on this account, like this contract on this very first account, that will be moderator. Okay. So this very first account will be moderator. For all of you, this account can be very different. For me, the moderator is, I'm copying this and I'm pasting it over here. That for me, the moderator is this account, this hash value, like this hexadecimal value. But it can be different for you all. It should be different, I think. So let's do that. So first you have to deploy this contract. When you will press on this button, you'll see that there is an object of this contract. So we will call it as a sample of this contract that is right now running, okay, deployed. And you can see that the account on which this contract has been deployed has lost some ethers. Okay, so some small value of ethers that is actually equal to the gas value that has been required for deployment of this contract. So you can see over here at the bottom there is one green tick. Okay, So let's see that what this represents. Okay, so it is saying that from 0x53C4, from this account, C4, this account, the very first C4, the contract election AsiaCon has been like that has been deployed. And when you will click on that, you will find that how much gas values it has taken. So it has taken 808,769 gas, and execution cost is this. So total amount, whatever is this, when you will add, that has been deducted from this. Okay. So now we'll come back. So now, so first thing is that because I'm the moderator, so I am in this account. Whatever account you will select, like here, 100 Ether, second account, is this moderator or not? Please tell me. The second account, the second one, is this moderator? Yes or no? No. Yes. Anybody else? Yeah. Okay. So this is not, this account is not a moderator. Whenever I will call a function, like suppose add candidate function, add candidate. So we must go to the add candidate function. Where is the add candidate function? Yeah, this function. This function says that the caller should be moderator. Caller should be moderator. And I'm not moderator right now. So let me call this function first. Check whether this moderator, this modifier is working or not. So add candidate. So I'm adding a candidate. Okay. Name. So I'm adding myself, and then I'm going to transact. Oh, so it is saying that when you'll see that it is saying that transaction mined but execution failed. And what is the reason? It is reverted that you are not authorized. What we have written for only moderator, go to only moderator, you are not authorized. That is here. The error with this thing, like condition is checked, although there was something, because we have called the function, so gas has been used, but the transaction has been failed, like transaction mined, but execution has been failed. So there was a transaction because there was a call of function. So whenever there is a call of function, and thus that function changes some variable, so that function needs some gas value, okay? Because there is some execution, there is a transaction, that transaction has to be added to a block and then all that. So it needs some execution money in the form of gas. So that is why, although the function fails, but the transaction has been mined. Okay. So this you should keep in your mind, like logical thing. Okay. Now let me keep myself as a moderator. I'm now becoming a moderator, C4. Again, I'm calling that function add candidate, and let's see. It works. It works because now I am the moderator. So let me check in the vote, like candidates 0, who is there? So candidate 0 has Samir, who has the vote count 0. Okay. Now let us take some random value, like a random name. So I'm adding another candidate. So Neetu Mekhla. We are taking Mekhla. So KHLA. Transact. Yes, because I am the moderator, I am not changed. So again, we will go to the 0 was Samir, 1 was Mekhla, and third one is Neetu. So Neetu. Transact. So there are 3 candidates. Okay. First one is Samir, candidate 0. Okay. Samir, candidate 1. Click on candidate, then Mekhla. For 2, candidate need to put 3 because 3 is not there. So it is saying debug the transaction, error occurred, invalid opcode and all that, because only there are 3 candidates. So okay, it works. Okay. So there are 3 candidates, 0, 1 and 2. 0, 1, 2, 3 candidates. Okay. Now we have added the candidates. Yes. So candidates are added right now. Now suppose I want to vote. I'm not a candidate, but I want to vote. So last one I'm taking as a voter. Now I want to vote. Vote to somebody like 0. Vote to 0. Vote to Samir. Let me vote myself. Just see that what happens. No, you are not allowed to vote because we have not given permission to this account to vote. So what we have to do, again, we have to become a moderator. So I'm taking this first one as moderator, going back. Okay. First, what we have to do, take again, I'm telling you, take the last account, copy that address. So that address will be some address of voter. So I'm again writing this thing. So I'm identifying voter 1 as this account. Okay, voter 1 that I've copied. Now I've copied this thing, and now I'm becoming moderator. So this moderator will give right to this voter 148. Give right to vote, but you should be moderator. So check it out. If I'm moderator, yes, I'm moderator. The copied address is what? The last one. Yes. Give right to vote. So we have given right to vote to the last account. Now you just become the last account. Now I am the voter who has been allowed by the moderator.